Welcome back to Sci-Fi Tech. In this video, I'm going to show you how to make a very exciting RGB LED Joule Thief circuit out of using these simple components. Let's get started. In an older video, I made a simple Joule Thief circuit out of these few components. It worked like a success, so I decided to improve this circuit by adding a few more components and make it an RGB LED Joule Thief circuit. And I'm going to use this type of RGB LED. This here is an RGB LED Common cathode. It's a very simple LED to use and requires only one resistor to be able to operate it. And the items that you'll need is these push button switches, this Toroid ferrite ring, a dead battery, a Perfboard, a Neodymium Magnet that came from a hard drive, some wire, and a 1K ohm resistor. A 2N2222 NPN Transistor. And what will make this circuit unique is I have right here some wire that is soldered onto a broken neodymium magnet. And an interesting thing is when you apply heat to a magnet actually loses its ability to be a magnet. So this is why I have my second neodymium magnet, and I actually plan on breaking it in half and using one half to stick directly on to that connection of the magnet, of the dead magnet. And I'm going to just use that to connect the battery to it. And as you can see, they barely stick together because the magnet lost its power from the heat. So breaking that in half, which is very easy to do, I'll have two pieces and it will stick onto the battery just like that. And that'll be my way to connect the battery. So now I'm going to go and take my wire, even it out, straighten it and even it together. And I'm going to put it through the Toroid ferrite ring. Put it in just like that. Pull the wire, straighten it out, and then do at least 7 windings. And as you can see, when you can't get the wire through, you can take an object, a pointed object like that, push it through, and that allows you to have a little bit of a gap to allow you to continue winding. And there, it is now complete. Okay, so now you separate the wires just like that. I remove the insulation, and you take the two center wires, and those two are what's connected. Those two wires connect. And by connecting those will allow you to be able to have an extended wire that will make a proper magnetic field. There we go, it should look just like that. Now I have my perf board ready, and I'm going to go ahead and solder in the switches. Now the first switch is soldered. Now time to solder the second switch. Solder it into place. Just like that. And now do the same thing again with the third switch. There, now my switches are in. Now I have my transistor. I'm going to go ahead and place it in just like that. Solder that into place. Take my 1K ohm resistor and put it on the base of the transistor. Solder that into place. Now I'm going to go in and cut the excess wire. Fold it over. Cut the other excess wire. Fold that over as well. And now solder it together to form an electrical bridge. Now I have my inductor ready, and I'm going to go ahead and take the wire, and I'm going to attach it to the resistor. Solder it into place. Cut off the excess wire. Fold it over to form a bridge. And now solder it together so it forms an electrical bridge. And there, now it's connected. And now what I want to do is I want to connect the emitter of my transistor to the second wire of the inductor. The wire that's on the other side of my inductor. Place it over just like that. Solder it into place. Snip the excess. Fold it over and then form an electrical bridge. There we go. Now the part of the inductor that's connected to each other just goes into an empty slot just like that. Solder it into place. Now I want to take my positive connector. That goes to the positive of my battery. And connect that right there. There we go. And now I'm going to go and put some more solder to form an electrical bridge. And there you have it. The two wires of the inductor is now connected to the positive. Now I have my RGB LED. And as you can see on this RGB LED, that longer lead is the cathode. And I want to put that on the second row on this Perfboard. Place it in just like that. Solder it into place. Fold it over just like that. Alright, so now I have my wire that I want to connect to the cathode of my RGB LED. And I want to place that right next to the collector of my transistor. There, it's right next to the collector. Now I'm going to go and solder that one wire into place. Now soldering the other wire. And now I'm going to go fold over the lead of the collector of the transistor. Snip the cathode of the LED. Bend the wire into place. And then form the electrical bridge. And now I've soldered the collector of the transistor to that wire which connects to the cathode of the LED. Now I have my negative connector. I'm going to place that next to the cathode wire to the LED and the collector of the transistor. Place that right next to it as well. And now the cathode of the LED and the collector of the transistor is now connected to the negative connector of that battery connector. Now I have right here what I call bridge wires. And this is just spare wires that I use to bridge things together on Perfboards. So now I'm soldering it together, and by soldering these wires together it makes it easier to make bridges. Soldered another one. Solder it again, which connects to the switch. Now I'm connecting all of the switches together. Now all the switches are connected. And now I'm going to go ahead and connect the wire that's from the LED, which is positive. It connects to one part of the switch. Cut off the excess. Solder it together. And as you can see, and now what I'm going to do is connect that wire to connect to the second switch. Fold it over just like that. Now I have another bridge wire. Solder it into place. Fold it over. And now that switch is connected to that LED. Now I have one more to do, and I'm going to use a wire to bridge it together to make it a little bit easier. So I placed a wire right there. Fold over that lead. Snip off the excess. Now form an electrical bridge. And now I'm going to go and move the wire. Put it into place. And now bridge that wire to the switch. There, now the wire is bridged to the switch. And this is what it finally looks like. And this is what it looks like when it's done. And as you can see, everything is now complete. So I'm going to go ahead and take my other neodymium magnet, break it in half. And simply place it on just like that. Take the second one and place it on there just like that as well. And now let's go ahead and test it out. As you can see, the battery is only 1.5 volts. Connect the battery in just like that. And then connect the other end. And now it's a closed circuit. Now let's go ahead and test it out. Green LED works. Red LED works. Blue LED works. Success. Let's see what it looks like in the dark. Blue, green, red. Now let's test it out in the complete dark. Pushing different buttons and connecting buttons together makes different colors of light. And as you can see, the blue and red and green works very well. Even when there's extra light, still works. And there you have it. Now you know how to make an RGB LED Joule Thief circuit with magnetic battery connectors. And there you have it. It's very simple and very fun to make. I really enjoyed making this device, and I'm actually really happy with this device. I may even do in the future improvements to make it a little bit more compact and a little bit more concealed so it looks even better, or something. I'm not fully sure, but I'll come up with an interesting idea to make this even better. But there you have it. I hope you enjoyed, and thank you for watching SciTi Tech. I hope you learned something new, and don't forget to like and subscribe for more SciTi Tech videos. Till the next tech. Goodbye.